Now let's look at MergeSort. MergeSort is one recursive sort. MergeSort. The MergeSort algorithm can be described recursively as follows. The algorithm divides the array into two halves, and then apply a MergeSort on each half recursively. After the two halves are sorted, merge them. So right here it's a simple MergeSort algorithm. So in this method, we take in one list array. If the list.length is greater than 1, then we do the following. If list.length is 1, that means that the array has only one element, so it's already sorted. We don't need to do anything. We sort the first half and then sort the second half. The first half starting from 0 to list.length divided by 2. Say if this list.length is 21, we divide it by 2, it will be 10. So from 0 to 10 will be 11 elements. So usually the first half is longer than the second half. And then we sort the first half and then sort the second half. And then we merge the sorted result together. Now let's look at this example. We got an array of 8 elements. We split it into two halves. The first half has 4 elements. Second half have another 4 elements. And then we further split into 4 quarters. The first quarter had 2 elements, and the same for the other quarters. And then the first quarter we divide it into 2 parts. And each one is only 1 element, so both of them are returned. After the return, we do merging. And the one smaller got merged in first, and then the bigger one. Similarly for here, 4 in first and then 5. 1 in first and then 8, and then 6 and 7. After that, we start to do the quarters. The first quarter merged with the second quarter. We set the 2 in first, and then 4 in, and then 5, and then 9 got sorted. And then same for this half. And then we combine the two halves into the resulting array. Now let's look at the method code. We get the list array coming in, and we create a new array. It's the first half array. And then we copy the source array list to the destination array, first half, both starting from the 0 position, and then the length is list.length divided by 2. We calculate the second half length by doing this. Create the second half array. And then we copy the source array starting from this index to the second half, the destination array, with starting index of this for so long. Both do MergeSort, and then we merge them together back to the original array. Now let's look at the merging part. We need 3 pointers: current 1, current 2, current 3. Current 1 pointing to the first half, current 2 pointing to the second half, current 3 pointing to the result array. If the current 1 and the current 2 pointing to the first element of each array, and they compare. If the current 2 is smaller, we assign it to current 3, the result array, and then we advance current 2 and current 3. Similarly, we continue to do that, comparing the element pointing by the current 1, current 2, and advance if that one got picked, until all of the index are out of bound. Then we stop. We have the result array. Now let's look at this merge algorithm. We have the list 1, list 2, and the temp. Temp is the destination array. So we have 3 counters: current 1, current 2, current 3. If both of the current index had not been out of bound, we continue to do this. We compare the value for list 1, current index 1, and the list 2, current index 2. If list 1 current index element is less than list 2 current 2 index element, that means this one is smaller. We put that into the destination array. Similarly, if list 2 element is smaller, we copy that to the resulting array. But this loop may be broken because one of it is out of bound. In that case, we need to check whether the other one had not been out of bound. If that happens, then we need to copy the rest of the element back to the result array as well. Then we finish the merge part. So for data structure, we have 2 options. First one, we use the original array. We copy the first hop to one temporary array, copy the second hop to another temporary array, and then eventually we merge it to the original list. This is the way we are using right now. There is a different way. You can just pass the index to the MergeSort part. So you store the first hop, second hop in the original array. But when you provide the result, you cannot override the original list. You need to create a new temporary list for them to merge. So these two ways are different. I prefer the first way. MergeSort time. That T of n denotes the time required for sorting an array of n elements using MergeSort. Without loss of generosity, assume n is a power of 2. That would be easier for analysis. So our MergeSort time for n element will perform 2 smaller sorting and then the merge time. And for n, we break down to 2 smaller cases. That will be half n. And the merge time is 2n minus 1. The 2n minus 1, n minus 1 comes from comparing the element for the if statement. And then n move to move element to the temporary array. That's for the copy part. So this finish the first recursive call. And then we recursively call another level. So we fully expand it, we will end up with such a result. So this will be a n log n algorithm. It is faster than n squared quadratic algorithm. So MergeSort's core is divide and merge on integration. Arrays.sort use MergeSort algorithm. So this standard method use sort algorithm. So let's look at the program. Our program is right here. The code is the same with the slides you saw. So I won't go into the detail again. The array for test is right here, and we put it into the MergeSort algorithm. After they are sorted, we print them out one by one. So let's look at the result. We need to compile it first, and then we run it. As you can see right here, -2 is the smallest, and then 1, and then 2, 2, and 2, 3, and 5, 6, 12, and 14. So please download this program and try yourself and try to understand it. This is probably a little bit difficult, but try your best. And let me know if you end up with some question. Thank you.